Welcome. Today we're going to be talking about acceleration. Today you're going to learn about how to calculate the acceleration of everyday objects and interpret the data given from a speed and time graph. Acceleration. Acceleration is a change in velocity over time. And what that means is if it's a change in velocity, then it's a change in direction or a change in speed. So there's two ways you can accelerate. Either one of these ways you'd be accelerating. If you're going down the road and you turn to the left, then you've accelerated because you changed direction. If you're going down the road and you step on the brakes, then you're slowing down, but you're changing your speed, so you're accelerating. Sometimes that's hard for students to understand that deceleration is still acceleration. It's just a negative acceleration. And then of course right here is our equation. VF equals VI plus AT, where VF is a final velocity, VI is the initial velocity. Okay, in this problem, to get up to speed, a car generates an acceleration. It goes from 6 meters per second. So this right here is our initial velocity. To 8 meters per second. So 8 meters per second is the final velocity. And it does it in 3.2 seconds. So 3.2 equals time. So if we use our equation here, I'm going to say 8 equals 6 plus a times 3.2. And what we would do with this is subtract 6 from both sides. You get 2 equals 3.2a. Divide by the 3.2. And a turns out to be 0.625 meters per second squared. Okay, in this problem here then it says an Olympic sprinter increases his speed in the last 3 seconds. So there's my time. 3 seconds, they just gave us the time. Then he started at 1.2 meters per second. So that's the VI. And he finished at 14 meters per second. So now let's find the acceleration. Using the equation, I'm going to say 14 equals 1.2 plus a times 3 seconds. Our acceleration turns out to be 4.3, and I've rounded that up, meters per second squared. Now if you've noticed on the last two problems, notice our answer here is in meters per second squared. Meters per second squared. That's going to be important that you start to recognize that that is what is the units for acceleration. Okay, here's the next problem. I want you to work this one out on your own. Okay, yesterday we said in a distance time graph, slope is the speed. But today we're talking about acceleration. Notice we haven't used distance in any of our problems. So what we're saying here then is in a speed time graph, we've talked about speed, velocities, and we've had times, the slope is the acceleration. Now I want you to notice here that from the way I'm labeling this, speed would be the y-axis and time would be the x-axis. Again, the y-axis is labeled first. So what this tells us here is we've got a speed and a time graph. So it's different than yesterday. Whenever we have speed and time, the slopes tell us the accelerations. So if I look between 1 and 2 seconds, 1 and 2 seconds, well this one's an easy one because it's a flat line. So what kind of slope do I have here? 0 meters per second squared. The reason is it's flat. At 1 second, the person was going 100 meters per second. At 2 seconds, he's still or she's still going 100 meters per second. So they have not accelerated, not at all. The next one is 3 to 4 seconds. So I've got to find the ordered pairs. So this ordered pair would be 3, and I'm going to guess it to be about 125. And then 4, I'm going to guess it to be 200. So there's x1, y1, x2, y2. So I'm finding the acceleration here. When I go to subtract that, that becomes 200 minus 125. And then we get 4 minus 3. So I get 75 over 1, which means my acceleration here is 75 meters per second squared. Well, hey, I want you to find between 4 and 5 seconds. I want you to find that. You're going to have to write down the ordered pairs. So you've got two things you're supposed to be doing here today. Finding that slope right there, and then I left you one problem right there. Hey, I'll catch you guys on the flip side.